Alright, so for this problem, we're given a function, f prime of x, so this is the derivative of f of x, and we're asked to find the local, or the x values of the local maximums and minimums for f of x. So the first thing we're going to do is split these up so that we can find where they're equal to 0, because remember, at local maximums and minimums, the derivative of the function is equal to 0. So f prime of x is equal to x plus 4 times x minus 4, and these two make up this. If you multiply these out, they're equal to this. Let me do the same thing here. 3x plus 5 times x plus 1, and if you multiply these out, they're equal to this. And so now we can find our x values, and they're going to be x equals -4, -5/3, there's the -4, -5/3, -1, and 4. And so if you plug in each of these, this will be equal to 0. Alright, so now what we want to do is take this and multiply it out so that we can find the second derivative. So f prime of x is equal to, actually what we're going to do is multiply this out because it'll be a lot easier to work with. We'll just take the x squared, multiply by each term, and then the -16 by each term. So we're going to get 3x to the 4th plus 8x cubed plus 5x squared. Now we're moving on to the -16, so -48x squared minus 128x minus 80. Alright, and now we're just going to simplify that. It's going to be 3x to the 4th plus 8x cubed minus 43x squared minus 128x minus 80. Alright, so now we're going to take this, find the second derivative. So we're just taking the derivative of this. It's going to be 12x cubed plus 24x squared minus 86x minus 128. Alright, now that we have that, we're going to plug in each of these x values and see if we get a positive or negative second derivative to find out if it is a local maximum or minimum. Because we know these are one or the other because the first derivative is 0 at these points. So we'll start out with -4. F double prime -4 is equal to, let's see, 12 times -4 cubed plus 24 times -4 squared plus 86 times -4 minus 128, and it's equal to -168, which is going to be a maximum. So if you remember, it's going to either look like this or that. This is negative, so it's going to be concave down like this one, which means that this is going to be our point. Notice the second derivative, or the first derivative is 0, represented by the straight line, and that it is concave down because of the negative second derivative, making it a local maximum. Next, we're going to use -5/3 f double prime of -5/3, and I'm going to skip the plugging in and just show you the value it's equal to. So that's going to be, you notice it's positive, which means it's concave up like this one. So that's going to be our local minimum. So let's look at f double prime -1. That's going to be equal to -30, which is a maximum. Because it is a negative second derivative, it's concave down, it's going to be another max. And then finally, f double prime of 4 is equal to 680, another local minimum because of the positive second derivative. So now we know that x equals -4 is our x value for a local maximum. X equals -1 is also a local of x value for our local maximum, for another local maximum, and then the x values for our two local minimums are -5/3 and 4.